All right, so what we're going to look at today is we're going to look at total surface area versus lateral area. Total surface area versus lateral area. And when we're looking at surface area, it's the area of surfaces. It's not supposed to be something that's a trick. So when we're looking at surface area and lateral area, there's a couple of things that you need to remember. The total surface area is the entire area of all surfaces, okay? So that's all the faces. This is including the bases. All surface area is all faces, including the bases. If I'm looking at the lateral surface area, not the total, if I'm just looking at the lateral area, I'm looking at the lateral faces. That's no bases. So no bases are involved. So let's look at some of these figures and let's kind of color in maybe, because I'm, quite the artiste, and see what we can do. Now let's look at the first figure. The first figure we have here, and we're going to name these, is it depends on how I have it marked. This is a rectangular prism. So I'm going to call this a rectangular prism. Now a prism has two opposite congruent parallel bases. That's what a prism. And we have right prisms and oblique prisms. And a right prism is when it's a right angle between the side and the base. And an oblique prism is like a slanted prism. So let's look at number 2. Number 2 is actually also a prism. I've got two opposite congruent triangular bases. So this is actually a triangular prism. A lot of people get this mixed up with a pyramid because they see triangle and the first thing they want to say is pyramid. A triangular prism is a prism with triangular bases. So that's a triangular prism. All right, so now we'll look at this one. This right here is a cylinder. You see cylinders all over the place, and we use cylinders. You talk about cylinders and engines. You see cylinders everywhere. Toilet paper rolls are cylinders. You see cylinders for soda cans. Everything that comes in a cylindrical container, that's a cylinder. This one here is a cone. It's shaped like a cone. You think about an ice cream cone. That's a cone, traffic cone, okay? Now down here, if I were to mark those, this is a square pyramid. This is actually a pyramid. A pyramid is a figure where all of the triangles meet at a single vertex. It's only got one base. A pyramid only has one base. Okay, so that's important. A pyramid only has one base. Okay, and it could be a square base, a hexagonal base, pentagonal base. So this last one, again, we've got two opposite congruent parallel bases. This is actually a hexagonal prism. Because what's the shape of the base? It's a hexagon. So now we've talked about the different types of prisms and pyramids and cylinders and cones and things that you're going to see. Let's go back up and let's see if we can identify the total versus the lateral. Okay, the lateral area is the area without the bases. The total has the bases in it. So what you need to do in each figure is let's identify the bases. Now with rectangular prisms, you can, it depends on which one you pick for the base. You can identify the opposite as the base, because in a rectangular prism you have 3 sets of options for bases. It just depends on the orientation of the figure. Just for our purposes, I'll go ahead and identify the bases as blue here. Those will be my bases. In my triangular prism, here are my bases. Okay. In my cylinder, here are my bases. They're circles. In the cone, here's my base. I only have one base. So the cone also only has one base. The cone and the pyramid, one base. In my pyramid, this is my base. And in my hexagonal prism, here are my opposite bases, the hexagons. So you can see how we identify the bases. Now the total surface area includes these. The lateral surface area does not include these. So if I'm looking at, for example, my cube, the red is the lateral. The red is the lateral. So if I'm just looking at the sides, That's the lateral. Here, that's a lateral, that's lateral, and the one in the back is lateral. The red is the lateral. It's the stuff around, it's the sides and the faces that surround the bases, not including the bases. If I look at my cylinder, here's my lateral here. It's just the label. If I look at my cone, that's my lateral, just the bottom portion of the cone, the funnel portion. For my square pyramid, the lateral would be all of the faces. The one in the back, the one on the side, everything except for the base. So all the red is lateral. And then in my prism here, all 6 of these rectangles that I have, all 6 of them are part of the lateral sides. So you've got lateral faces. So now we've got a distinction between bases and lateral. So when I want to find total surface area is actually going to be both. So we're going to do total surface area versus lateral area for each one. So for my rectangular prism, the total surface area, if it's a cube, I'll make a little note, if it's a cube, then your surface area is 6 times one side squared. Because what's the area if in a cube? Well, all sides are the same. They would all be the same value, so I could just square one side to get the area of the square and then multiply it by 6. If it's not a cube, you can add all of the rectangles together, base times height plus base times height with all the different values, or the shortcut is 2b plus ph. Now what does that mean? Capital B is the area of one base. Capital P is the perimeter of the base. And H is the height of the prism. Now the height of a prism is the distance between the bases. So since I designated these two as bases, this would be my height right there. Or this could be my height. Or this could be my height. The height is the distance between the bases. You got to remember that. So the total surface area here is 2b plus ph. So what would the lateral area be? Well, what do we know about lateral? Lateral area is no bases, right? So the lateral surface area, what would I drop off? The 2 bases, right? So the lateral area is just pH. And those are your formulas for the rectangular prism. Total surface area, 2b plus pH. Lateral area is pH. Let's go to the triangular prism. Well, triangular prism is going to have the same formulas. Why? Because it's a prism. All right. Now, if I look at this, okay, my base, I would do the perimeter of my base. The height of my prism is right here. This is where people get confused. The height, remember, is the distance between the bases. If I were to set this prism upright on one of its bases, the height is the distance between. So you have the same formula for these two, the exact same formula. You would also have the exact same formula for the hexagonal prism. You would have 2b plus pH, and then you would have the lateral area as just pH, because it's a prism. All prisms are the same. The height of this one is this, because what is the height? The distance between the 2 bases. Okay, so now let's look back over here. I've got the lateral area and the surface area for a cylinder now. Well, we have an interesting thing we call a net, where you can unfold all of these things, and we'll look at that, the rest of the nets, in a different video. But if I were to unfold a cylinder, I would actually have 2 circles and a rectangle. So if I wanted to find the total surface area for a cylinder, it's the 2 bases. And what's the formula for the area of a circle? Pi r squared, right? How many of those pi r squareds do I have? 2 of them. 2 pi r squareds plus whatever the area of this rectangle is. Well, what is the area of a rectangle? It's base times height, right? Well, that's the height, isn't it? So how do I find this? The base. Well, think about it. When I fold this up to make my cylinder, what does that rectangle wrap around? It wraps around the circle, right? How do we calculate the length around a circle? You're right, circumference. So the length around my circle here is 2 pi r, right? So wouldn't that mean that the rectangle would be 2 pi r long? So if I want to do the area of the rectangle, it's 2 pi r times h. And that's how you find the surface area of a cylinder. Now if I wanted to do the lateral area, what would I drop off? The 2 bases. So it would just be 2 pi rh, the rectangular part. And those are your formulas for the cylinder, for surface area and lateral area. All right, let's look at the cone. If I look at a cone, and I want to do the total surface area of a cone, my markers are not cooperating with me. If I want to do the total surface area of a cone, I have one base, and that's a circle. So what is that? It's pi r squared plus, this is where we have to get a little creative. In a cone, you have 2 different things, or several things. You have the radius, and you have this in the cylinder as well. The radius of the cylinder, the r, is right here. That's the radius. And this is the height, okay? And then we have what we call the height of the cone. And then we have what we call the slanted height. That's L, that's this. The lateral area of a cone is pi rl. So if I want the total surface area for the cone, I want the base, which is pi r squared, plus the lateral, which is pi rl. So if that being said, if I just wanted the lateral area, I would drop the pi r squared off, and I would just be pi times r times l. Now don't get the slanted height confused with the regular height of the cone. The regular height of the cone is, we'll use that in the volume formula, but not in the slanted, not in the surface area. So let's look at a pyramid. Okay, surface area of a pyramid. It's the area of the base, and I'm going to put a capital B. And the reason I'm not doing pi r squared or anything like that is because pyramids have all kinds of bases. It could be this. Okay, or sorry, it could be something like this. It could be a hexagonal base. It could be a hexagonal pyramid. It could be a triangular pyramid. Whatever the shape of the base is, you find the area of that. Then, if you want to add the other part, it's 1/2 the perimeter of the base times L. There's that pesky L again. The slanted height of a pyramid goes from the vertex to the center of the side. Okay, whoops, right there. The vertex to the center of the side at 90. That's a slanted height. That's a slanted height. If I wanted the actual height of the pyramid, I would go down into the middle and make a right angle. But we don't use that except for volume. Okay, so if I want to do the lateral area then, if I want to do the lateral area, then I'm going to drop the base, so it'd be 1/2 PL. Okay, and that is a quick snapshot, not really quick, of surface area total versus lateral area and how we look at these figures. So one more look. You can see the blue ones are the bases, the different types of figures that we have. The lateral area is represented by the red portion. The total surface area is represented by purple. Notice I did that. Red and blue make purple. Pretty smart, right? And then the lateral area is just the red for each one of these. In the hexagonal prism, same formula as the other prisms.